right. Hope you guys can hear me. So yeah, I'm going to talk a bit about building RAG, something that I care about a lot. First of all, we could just start with who am I? My name is David. I got my master's degree in computer science back in 2019, where I specialized in natural language processing and machine learning. I live in Aarhus with my girlfriend and my dog Ruby, which I'm not afraid to use as a cheap trick in my pictures. And I've also worked for Trifork for 5 years now. The agenda for this talk is I'm going to start with trying to motivate both why do we use Retrieval Augmented Generation or RAG, but also try and explain what I mean when I say performant in this case, because there's many different assets or facets of how performant something can be. Then I'm going to introduce the use case as well, because for the next steps, I'm going to go through iterations of a very homemade fake use case. And I'm going to try and introduce different issues or problems and then try to solve them using different techniques. And kind of the idea is to show you a specific use case and then kind of solve that use case using a technique. And then maybe you can apply that in your own applications if you are trying to make RAG. So yeah, let's start with the motivation. Why do we want to use RAG? So first, if you're talking about you want to make applications using LLMs, you can say there are maybe two different approaches. One approach is like after the LLMs have started to have like hundred thousands of tokens for context, you can just take the question and then supply your whole knowledge base to that context, and then it'll be able to answer the question. I would say that this is not a very cost-effective way of doing it. While it might work, it's not necessarily very reliable due to different issues you have with LLMs. RAG is a more context-specific approach where you try to figure out what is the right context to answer this question on the fly, and then you only supply this context to answer the question. And this has some benefits in like the cost is easier and it can be more reliable and more flexible when the data changes and stuff like that. So what are the phases of RAG? It's split into 3 phases. If you look at the literature. So first is the indexing phase. And in this phase, you basically take a knowledge base and then usually you would try to use embedding models and then you would embed these text as chunks into a vector database. That's the indexing part. Then you have the retrieval phase where you embed the query, usually using the same embedding model you use to index your knowledge base. And then you can use similarity search or vector search to find the relevant documents for your question. And then in the end, you have the generation phase where you supply both the relevant documents as context and the query to answer questions or kind of get your output for the pipeline. And in this talk, I'm going to be focusing mostly on the retrieval phase and the indexing phase because RAG is very dependent on retrieving the right documents to answer your question. When I say performant RAG in this talk, like you could think maybe it would be like very fast or cost effective. This is not what I'm going to be focusing on. So mostly I'm going to be focusing on how do we make a RAG application reliable. Like if you want to have a RAG application and supply something to customers straight away, then you want it to be relatively reliable because it doesn't make a good showing for a customer to see something random or some hallucination and stuff like that. So I'm going to be focused on how to make our pipeline reliable using pretty simple techniques. And there's going to be code. And I hope it's big enough on the screen, but the repo will be supplied after the talk. So if you want to play with it yourself afterwards, you can do that as well. The use case we're going to be using or looking at is something that I have some experience with, working with different customers, which is generating drafts to answer support tickets. So basically, we want to be able to have all the support tickets as a list, and then when the ticket comes in, we just apply it to the RAG pipeline, and it'll automatically make a draft which the customer support supporter can then use to answer the question. All right. So, as with most machine learning, and I would say all machine learning, usually you want to start simple and see if that works. The first iteration of the use case, we have a single product called fake product. All these documents are just generated using LLMs. The tickets are short and they always only contain one question. This is quite important. And we only have a single document that we have a structured list of questions and answers. So it's pretty structured. Here's an example of how the guides look. So we have the question, what is the fake product? And then we have the answer that the draft should contain. All right. So when you're making simple RAG, they've developed some approaches that are pretty normal to use nowadays. It's always developing a lot, but one of the main ones that I would always use in a simple approach is something called hybrid search, where you're mixing different search approaches while you're trying to retrieve data. And in this case, I'll be using something called, so the normal or baseline RAG uses vector search, where you use dense embeddings. And then I use something called keyword search using sparse embeddings, which is sparse embeddings being embeddings with more zeros, and usually these are good at capturing keywords or specific details of a text. And then we kind of just compute a hybrid score. And when applied to our use case, we take our support guide and then we embed it into our vector database. I'm using Quadrant in this case. Then we're going to take the email body and supply it to our retrieval or hybrid search module, where we get the relevant docs or documents. And then we'll generate a draft using a bit of prompt engineering to allow us to only get the answer out of the text. So let's just look at that. So first of all, let's look at a bit of code. So why this is simple. So I'm using a framework called Llama Index, you might have heard of, in Python. And I'm not really doing much code to generate this example. I've already embedded my so I've embedded my context database simply here using simple populate DB, where I decide that it should be a hybrid. So I just tell Quadrant that I'm using hybrid search, so therefore you have to embed it using both sparse and dense embeddings. Then I have our create draft function, where we just tell it we're using hybrid search as our query mode, and then we supply a prompt where I tell it that it's a support worker, usually having some sort of context that how is it supposed to answer is very helpful. And then I tell it to say hello, thank you for reaching out, and end the text with please let me know if you have any further questions. And then I supply the context and the query. And so we'll try and see if the demo gods are happy with us. So I've made a small demo here just to show you that it works. So let's try and create a draft from this question. There we go. So it answers here, hello, it listened to us, and then the main features are this. And the sources we used are the following. So that's pretty easy. So if the question fits very well, the simple case works, and we have different questions that can also be answered pretty easily. So that's the first iteration. So it's very simple, but it's also a very unlikely use case that you would just have this sort of very, very structured knowledge base. So let's go back again. Oh, that's the code. So in the second iteration, we're going to change the use case a little bit. So now we have multiple products. There's fake product and there's fake product 2.0. There's also fake widget and fake app. Then we also now have tickets that can contain multiple questions. So these questions will not be pre-sorted. They can be contained in one sentence. All of this. So also, the one problem we also have now is in our support guides. Here's an example of something I've tried to introduce that would be an issue. Fake AS who make fake product, they don't wanna use the fake product 2.0 name, so it's just still fake product, which means in the context you still say fake product. So these texts are quite similar. The only problem is the actual number that the price is for the different products. And how do we use like vector similarity search, which is just based on embedding models and placing text in an embedding space? How do we ensure that if we gave the model these two context, how does it know which one is which? And we're gonna try and solve this problem. Here's an example of the tickets, multiple questions, and we haven't sorted them into any categories at all. They're just one big email. So first, we're gonna try a technique called query expansion. It's basically if you consider divide and conquer. So taking a query, we'll try and just make an LLM say, okay, which questions are involved in this query. We're also going to use something called metadata filters, or it's just a simple filter. So we apply when we embed our document into Quadrant. Then we're going to kind of just tell it, here's the topic, or here's the product that is this node is based on. And then we're going to use an LLM to decide for each question, which filters am I going to use? And when we apply to this use case, we have our documents, which just did specific files. Then we put the product in as a metadata for each node. Then we'll use query expansion. So for example, how secure is fake product versus fake product 2? You can consider two questions. How secure is the first one and the second one? And then we'll decide, okay, so the query, how secure is fake product, will use the fake product metadata filter. And just as a nice bonus, we're just going to use an LLM at the end to summarize all the answers into one draft for the question. So yeah. If we look at the code, we've defined kind of all the products as in a list here with the names and descriptions. And then we just define the different tools. This is basically a description of each filter. So this question answers about the product, and then we have fake product 1, 2, and widget and stuff like that. Then we try and generate some questions using the email body. And when we've generated those, we actually, this is something supplied by Llama Index. So we actually also tell it, these are the products you can already categorize each question in. This also helps the model know how the question should be formulated. And then we'll just answer each one and summarize at the end. So let's try and look at this. So when we look for the main features of fake product, this is kind of a tricky question because are we talking about fake product 1 or 2? It's not really mentioned in here. So hopefully if the demo guides are nice to us, it answers both the questions. And for each question, we say 1.0 and 2.0, then we can supply both answers and actually answer the customer's question. So that works. We can also look for differences and other stuff, but basically that's how it works. You develop questions and then use filters to limit your search space for that one question, and this allows you to know that you're getting the right context, or at least you're more sure and reliable way to get the right context for that question. All right. So let's look at the next iteration. So again, we're going back to one product, but and the tickets may still contain multiple questions, but now we don't have very organized documentation. So this is probably more likely the way documentation will be supplied, because usually it's not made for answering questions. It's just made for here's some knowledge about something that you need to answer questions about. So here's an example of the support guides now. So basically, it's just sections, and when they ask about this, you can talk about this and this and this. So there's actually multiple questions in each section that can be answered. So it's not questions anymore, which makes it harder to search for the right answers. And yeah, there's multiple different questions. So how do we solve this, or what's the way to get to enable us to get the right context without actually being able to search for the questions that we are being asked? A way to do this is by decoupling the documents that we're searching for from the one we're using for synthesis or generation, whatever you want to call it. And there's a technique called summary or question indexing or sentence window. And this is basically we are limiting the space we're searching to a sentence or a question or a summary. And for the summary index and the question index, we actually just use an LLM to generate the questions. This way, we can use our knowledge base for answering questions, which is what it's used for. And then we can use the questions to actually search for the right knowledge. So how do we do this? So first of all, we fetch the chunks. This being Markdown is pretty easy to fetch in a way where we actually just fetch each section of the document, which is nice. Markdown is very nice for RAG. And then we just generate a question for each chunks. I just say, okay, let's generate 10 questions that this piece of text will answer. And then we embed the questions instead of the knowledge that answers it, but we supply the original text as metadata to each node. Then when we retrieve the text, we search for the question nodes, and we kind of just say we don't care about the question. The question doesn't even have to be like exactly the same or relevant. So we don't need it to answer the question that the customer has. So instead, we just replace the text with the original text that has the question as an answer. And then we just, because we're generating multiple questions for each piece of text, we might get the same text multiple times. So we just try and distinct these, and then we'll end up hopefully with the right text nodes. So let's look at that. So basically, this is also pretty easy. We've already if we look at the database, we take each document, this one document, and then for each kind of small section of the document, we generate questions. Here we'll just generate some questions, and one nice prompting technique to use. I'm not sure what others name it, but I would all call it I go, you go. So basically, we're saying, okay, here's the text. Now questions, then you go, and then it will generate the questions. This way, we won't get the problem with LLMs. And sometimes they'll be, oh, sure, I'll generate this for you. Here's a list, and this way we just kind of just say, okay, we don't need that. Just generate the questions. And then we just use these like node processors for the retrieval phase, and then this way we'll supply the right context. Let's try that. Let's look what's the price for the basic plan. And here we have the text that used to answer the question and the question that was used to search for it. And this can be used in many ways. Like there's also summary indexing. So if you're trying to answer more complex questions, sometimes you just you have a large piece of text, but you want to summarize it and then search for the more key points of it, and then you can use the whole text to generate afterwards. So yeah, that was the third iteration. So let's look at the last iteration here. So this one gets a bit more hectic. Fake AS, they come to us and say, we have some more things. We still have a single product, and there's still multiple questions, but the users might be asking questions about how their plan is based, like how long until it ends, and this is not something we can just hard code into our knowledge base. This is dynamic, and it might change at a moment's notice. So we have some dynamic context that we want to supply based on the user. You can imagine it like if you want to supply the weather for as a context, then you have to use some sort of API to get the current weather to answer the question. Also, they have some ideas that if you have angry customers, they don't really want an AI to answer their questions. You want to really placate them in some way. So we just want to not answer questions using AI for angry customers. And yeah, so here's a question. So I've just, in my example, the user ID is applies in the from. There could be other ways of catching this, but the email body contains the user ID. So the user ID is just supplied in the text. It could be supplied in the middle of the text or anywhere, and then we just use LLMs to actually extract that and search for what we need. Then Fake AS, they also have this API to get the plan info for each customer. It takes the user ID and then it supplies the plan info. So yeah, so let's try and see if we can implement that. And one of the techniques we're going to use is query routing. And query routing is a way to make your pipeline more adaptable to specific situations. So imagine that you have 3 different knowledge bases that you want to use for different contexts. Then query routing is a technique where you take the query and then you ask an LLM, which of these pipelines should I use to answer this question? And this way you can, for example, implement the filters, or you can decide, okay, if the question contains something about the user's plan, then we need to use the plan pipeline to supply that context. And also we can extract the user ID to actually answer the question. So how do we implement this? I know the text is probably a bit small, but yeah, we will start by adding some filters. So we've just described this to the LLM. We don't want to answer when the user seems angry or if they're referring to a previous interaction, because they haven't supplied an API to actually look at this previous interaction. And yeah, so the red part here is we actually, based on these filters, we say to an LM, is any of this true in the text? If it is, then we just skip everything. Then we have one part which is just a basic product pipeline that we've seen in the other examples, using a retriever, a regenerate. And we also have a pipeline to look up user data. And we kind of try and describe each pipeline for the AI. So we just tell it, this one is useful for answering questions about products, and this one is useful for answering questions about specific customers and their user ID. So, for example, if the user is very unhappy with the service, then we want the filter to just kind of say, all right, skip it all. We just don't generate anything. Maybe we want to give the reason why we don't generate it, but then we can at least log that. Then what is my current plan with an user ID? We say, all right, that just goes to the customer you look up pipeline, and we can see that they have a basic plan. And again, if they're just asking about the product, we just want to use the same pipeline we've been using the whole time. But there could be questions that actually involve both of the pipelines. So we also want to be able to say, all right, if both of the things are present, then we want to answer both questions using each pipeline and then kind of fuse them together in the end to generate an answer to the whole question. So yeah, all right, let's look at this. So this got a bit more complex because Llama Index didn't supply something to filter. You also generated a workflow. The workflow here starts by having the filter step we looked before. So we're just saying, all right, you're a helpful assistant. You need to answer whether we should stop or we should continue. So this is the only answer we want. And then I'm using something called few shot prompting, which is basically just provide a few examples so the LLM is better handled to answer your to answer your question. And yeah, so I just supply the listers as a parameter to this workflow, and if it goes well, then we continue the workflow, and then we go to the query. So the workflow, it doesn't itself use the routing. I just supply a query engine where I can just supply a query engine that actually use routing. So we're going to get back to that. And then in the end, we're going to refine the whole thing using all of the sources supplied by the query engine, just to refine the whole thing. So when we define this, we'll get the tools. So I've defined my my normal product engine here, which is still a hybrid search. And then I've defined a new customer query engine, which is quite simple. It just it uses an LLM to extract the user ID, and then it just applies for each user ID. We query the service, which is for me just simple fake service customer DB, and it'll look those up. Yeah, so that's basically it. Let's try and see if that also works. Gotta change it here. So, all right. So this one is for user 456, and they sound like they're pretty unhappy. So let's see if the filter sets in, and if you look at I've tried to make some colored notes here. So we're stopping the workflow because the user seems angry, and also if the user talked about something last time, then we wanted to answer with no. He's conferring to something we talked about previous, which is not good. Um, then what if the user just asks for my current plan, and the user 456 has the current plan? So we can see here we're selecting the question about the customer's plan, and it even supplies why it selected that engine. And then the user has the basic plan, and it ends on May. And the question will then be, yes, you have the basic plan. And if we change it to another user, then it should find that they have a different plan, and then it'll change its answer based on that. Yes. All right. So they have the pro plan. So let's look at this question. So this is one that gets a bit more tricky. So first of all, we want to know what's the price plans for fake product. Also, what is my current plan and the amount I pay for it? So this is kind of a conjunction of questions that basically we want to know what plan does the user have, but also what are the prices for the plans, and then answer the question based on that. So let's try and create this. And if we look at the log here, then basically we continue the workflow because it's not hitting the filter, and we're selecting both of the query engines because both of he's asking for price plans, which is the product pipeline, and then he's also inquiring about the current plan. And then in the end, we use kind of the refine step, which is where we just take the whole thing and mix it together. And the existing plan was, yeah, all right. So the refine answer is a bit better. And then we can say, all right, so you have the pro plan, and it costs $79 per month. Here's the other plans, and the source is both what are the pricing plans for fake product and the user's data from the API. So this works pretty well, and this could be fit into any. You could have a number of different pipelines. You can also just have different pipelines for the same workflow, but with different categories. So instead of using meta filters, you can just have different query engines for different categories of products. So yeah. So let's just talk about in the end here what some of the key takeaways from this talk should be. So I've kind of tried to, by supplying a very simple made up example, try to supply some problems you might hit if you're trying to make RAG pipelines. First of all, I would always start simple, see whether that works, figure out if is this all right, because it's so easy to make a simple RAG pipeline using some of the frameworks that are available right now. So yeah, start simple, base architecture. Then we've looked at some of like divide and conquer techniques where we can use query expansion to kind of say each question for each all the question for the customer, and then search for them individually, and then this will make it easier to make the pipeline reliable in a way that selects the right context for the right questions. Then we're looking at decoupling the retrieval documents from the generation documents, also enabling us to allow how do we search better for this. Imagine they could both have questions and other things, and you might want to have a question pipeline where you can search for questions, or if you want to search for summaries of things. So this is also very useful. And then we're trying to make the whole pipeline more adaptable, so it can actually react to different scenarios where it needs to act differently based on some context provided by the query. And I could honestly keep going with different techniques. This is a very fast moving area. There's some interesting techniques using knowledge graphs and generating fake answers that are not even true, and then using that for search, and then re-ranking, and also fine-tuning LLMs specifically for RAG. So there's so many different techniques you can use to solve different problems. I've tried to apply the ones I feel like could be most useful for proof of concept or for using in a real project. But all the others are also very interesting. So I recommend looking at those as well. But yeah, I think that's actually it for my talk.